A study involving stress is conducted amongst the students on a college campus. The stress scores follow a uniform distribution with the lowest score equal to 1 and the highest equal to 5. So here are the key words here. And we have a sample of 75 students. Our graph is going to look like this. We have frequency, of course, is always on the vertical axis, and scores are on the horizontal. We have scores of 1, 2, 3, 4, 5. Because it's a uniform distribution, I know that my bars are all going to be the same height. All right, so which tells me that I know that my mean is going to be right in the center because that's the halfway point. It's going to be the average. Now we can visually see that it's going to be 3, but if we want to use the midpoint formula to be sure, remember the midpoint formula is we get the highest value, the lowest value, and we divide it by 2. So that will give us 6 over 3, or 6 over 2, sorry, which is 3. So this is going to be our mean for our uniform distribution. And so I'll label that M with a little u down here. That's the mean for our uniform distribution. And then the standard deviation for our uniform distribution, I don't know if I ever actually gave you this formula, but you can look it up real quick. Just Google it or look it up in your book. The formula for a uniform distribution for the standard deviation is you take the maximum value, which is 5, then you subtract the lowest value, which is 1, you square it, you divide by 12, and then you square root it. This is part of the formula here. This will always be 12. This will be your maximum minus your minimum, and then you square it. And then once you divide by 12, the last step is to take the square root of all of it. Now when we do this, we get 1.15. So this is our standard deviation for the uniform distribution. Okay, so we're going to use this information to answer parts A, B, C, and I think there's a D also, yep. Okay, so in part A, it says the probability that the mean stress score for the 75 students is less than 3. So we're looking for this. Since we're using the sampling distribution, we're looking at the means of all the samples, and we want to see what's the probability that the mean is going to be less than 3. Because of the central limit theorem, we know that the sampling distribution is going to be close to normal or approximately normal. So I can envision that our sampling distribution, our x bars, is going to have this kind of a shape. The mean is going to be the same as the mean of the uniform distribution, which is 3. And our standard deviation for the sampling distribution is going to be whatever the standard deviation is for the previous distribution, in this case our uniform distribution, and then you divide it by the square root of the sample size. So this is going to be our standard deviation. Now, because we're looking for where x bar is less than 3 and we can approximate it using the normal distribution, I'm just going to use my calculator and do normal CDF. So I'm going to put in normal CDF. I'm going to put my lower limit, which since we're doing less than 3, this is what we're looking for. So less than 3 means we're going to go all the way to the left. So my lower limit is going to be -1 E99. Our upper limit is going to be 3. Our center is 3. And then our standard deviation is 1.15 divided by the square root of 75. So when I put that in on my calculator, you're going to find that you're going to get 0.5 it might even be like 0.5000000 something else. It's going to be really close to 0.5 though, which makes sense because if we're looking at the center and we're looking at what portion of the graph lies to the left and we're looking at the center, that would be 50% or 0.5. So that works out pretty well there, that we can visually check it. Okay, for the 83rd percentile, again, we're using the sampling distribution here because it's asking about the mean stress score of the sample. We want to find the percentile, so we're going to do inverse norm. We're going to put in our percentile, which is 0.83. We're going to put in our mean, which is 3. And then we're going to put in our standard deviation for our sampling distribution, which we found was up here. 1.15 divided by the square root of 75. When we put that in on the calculator, we're going to get approximately 3.1267. We can stop there. So when we look at that on the picture, here's 3 in the center. 3.1267 is going to be a little bit over here somewhere to the right of 3, which means this is going to be our cutoff point. So that anything to the left here, that's 83% of the data. So that makes sense that it's past the 50% mark, so we can verify that looking at the picture. Okay, the next example says, find the probability that the mean is greater than 7. 3 is here in the center. 7 is going to be way, way off here. Way, way far out. Because we see that the 83rd percentile is at 3.1267. So 7 is going to be way far out there. So we're looking at what's the probability that you're going to get just this little tiny bit here. It's going to be close to 0. So we're going to use normal CDF. We want to do our lower limit is 7. Our upper limit is 1E99. Our mean is going to be 3. And our standard deviation is 1.15 over the square root of 75. Yeah, it comes out on the calculator to 0. All right, now this last question, it says find the 42nd percentile for the mean of 55 scores. So notice the sample size has changed. So the only thing that we have to change is instead of doing a sample size of 75, when we take 1.15 and divide by the square root of 75 for our standard deviation, we just now have to divide by the square root of 55. So we're going to do inverse norm. We're going to put 0.42 and then a mean of 3, and then our standard deviation is 1.15 over the square root of 55. And when we put that in on the calculator, we get about 2.968. It looks like we would round that up to 7. So here's our 42nd percentile for samples that have 55 scores rather than 75.